About the STAAR test, uh, it's more like a compliance check. Every year they make you guys do STAAR test to see if you guys are ready for the next grade or not. If somebody has a serious problem, like somebody has not understood anything and gets anything below 35%, that is when that becomes a serious concern. It's not that if you don't get to 35%, you will be put in the same class, but they will give you some more assignments, they will make you do some more activities so that you get ready for the next grade. That's the only thing. But whether you're getting 95% or 45%, in both the case you will pass, and that will not add to your grade also. STAR test is only a compliance check, say okay, this guy is ready for next grade.
Yeah, what happens if you get 73% or above?
It doesn't add to your grade. Anything above 35% just tells you that okay, you are good for the next grade. That's it.
Okay.
That's what I know. I have not studied in US, I have studied in India. That's what I know from my kids, and that's what I'm learning and hearing from you guys. Okay, so I would not want to stress out for STAR test, but it is a test which is meant with a done with a purpose. The purpose is to make sure that you know what you're supposed to know for being ready for the next grade. Okay, so here in this class we have Mitran in 7th grade, Dikshita also in 7th grade, correct?
Yeah.
And Srivatsav, you are in 8th grade, right? Yeah. What I want you all to do is, see, we have learned certain things. Dikshita has joined recently, so she knows what she knows without being in the class. What I want you guys to do is, between today and tomorrow, spend 30 minutes or 45 minutes, sit together and tell me what are the topics in maths that is going to be covered in STAR test.
Okay.
Let's say so Dikshita, you will do it for 7th grade. I want you to write down what are the topics. Let's say be it exponents, be it finding out area, volume, be it all the subjects, all the topics that you need to know, or you have to do algebra 1. So list down everything that is going to be there as part of your STAR test, and we'll have to check what all we know, what all we don't, and whatever we don't know, how do we catch up on that. Okay? Yeah. So Mitran and Dikshita will write down for 7th grade, and you guys will show it to me. Either you send it to me in text message.
I think I already wrote it down.
Okay, give it to me.
I actually wrote it on the STAR test practice paper if you
okay.
need it.
If you just read out the topics one by one.
Okay, the first one is quantitative reasoning. The second one is pattern, relationship, and algebraic reasoning.
Go step by step. Go step by step. First, so in today's class, what we are doing is we are just trying to check what all we know, what we don't, so that we can prepare for it. So, Srivatsav, do you have that listed down anywhere? Like what all you need to prepare for your STAR test? All the topics?
I think I do.
You have it? Okay. So let's go step by step. So let's hear it from Mitran first, then I'll come to Srivatsav.
Okay. So the first one I wrote is quantitative reasoning.
Quantitative reasoning, okay? Quantitative reasoning, okay?
Second one is pattern, relationship, and reasoning, and algebraic reasoning.
Relationship
and algebraic reasoning.
And algebraic reasoning, okay? Okay.
The last one is data analysis and probability.
Data analysis and probability.
Yeah.
And probability, okay? So these are only 3 topics?
Yeah.
Okay. So that is what Mitran said, okay? The 3 topics: quantitative reasoning, pattern relationships and algebraic reasoning, and third is data analysis and probability. So these are three things that Mitran said for grade 7. Dikshita, I would want you to validate that and let me know if there is something that we are missing here. Okay? Yeah. Now, coming to Sivatsav. So Sivatsav, what are the things that you have noted down so that we can go over them one by one?
Yeah. So, Unit 1, real numbers, 2, equations and inequalities, 3, volume and surface area,
Okay.
4, linear relationships, 5, transformations,
Okay.
6, data and statistics,
Okay.
7, financial literacy.
That's it.
Yeah.
Wonderful.
Oh yeah, I also forgot to mention financial literacy also.
Okay. So what was the last topic you said? Financial
Literacy.
literacy. Okay. All right. So let's start with we'll pick up the simple ones first. Okay. So real numbers, equations, linear equation, then okay. Or let's start with the 7th grade and then we'll go to 8th grade. Okay. So let's start with quantitative reasoning. This is a topic. This has nothing fancy about it. This is one of the most relatable topic that we can talk about. Now let's look at one question. Okay, you tell me one question that you have come across this, or else I will ask a question. Either way is fine. Okay. Or let me help you guys. Quantitative reasoning or patterns or relationship. Let's look at that. I will look for a specific topic again. Okay. So what you have given me, that might have certain subtopics underneath. Okay. I want to further break it down also. Okay. When you say quantitative reasoning, do you have the book here? Can you just
Yeah, I wrote it on this top 3.
Okay, top 3. Is this a book or?
No, actually, this is the STAAR test practice sheet that I did.
Oh.
But I had to like write it down somewhere, so I just wrote it on top of this.
Can
I can
you
write
do-
it down on the notebook if you want.
Yeah. So I want you to note down the topics and subtopics inside that. When you say quantitative reasoning, what are the different topics that comes inside that?
Oh.
Because here,
So you talk about only simple topics, not complex one.
no, I'm saying when you say quantitative reasoning, what I'm trying to do is I'm trying to break it down, like what Srivatsava did, right? Quantitative reasoning. This is one topic. Inside that you will have probably 2-3 things that you have to do. Okay, dealing with number system or whatever it is. Okay, I want that listing so that we can come back to that. Okay, we can cover all the topics inside that. And send me this one from your dad's number also. Once you
Okay.
go home. What I will do is I will also look at the subtopics inside that so that we can start doing that from tomorrow. Okay. So let's whatever Srivatsava said, that was more specific. So let's go through those topics one by one. Okay. So Srivatsava, what was the first topic?
Real numbers.
Real numbers. Okay. So let's start with the basics. What all do we know? We know
There are different categories of numbers.
yeah. So I'm starting with the basic. These are called natural numbers. 1, 2, 3, 4, 5, 6, 7, 8. Go on as far as you want to go. Those are natural numbers. Okay? Add a 0 to it. That becomes a whole number. So natural numbers have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You keep going as far as you want to go in the positive direction.
But whole numbers include 0 in it.
Whole number includes 0 also inside
Okay.
that. And if you add negatives also, like -1, -2, -3, -4, this whole set becomes integers. So integers have positives, negatives and 0. If you take out the negatives, what you are left with is whole number. That is 0 plus positives. If you take out 0 also, that what you are left with is natural numbers. 1 to infinity, all positive. Okay. So this is the basic one. Now comes fractions. Now these were all full numbers. Now let's look at these numbers. These are called fractions. Now, if you look at only the positive fractions, these are called fractions. If you include the negative ones also, okay, and there could be many more. These are called rational numbers. Okay? Are you guys with me so far?
Yeah.
Only positive fractions are called fractions. If you put all positive fractions and negative fractions also together, that's called rational numbers. Okay? Now, these are the variety of numbers. Here, numerator and denominator are whole numbers. Okay? Now, look at another one. What is this? This is pi, value of pi. Do you know what is the exact value? If I convert that to decimal, what will it come out for? No. It doesn't stop. You don't get a perfect value for this one. So there is no stopping here. Okay. If you divide, let's say, or any number, when you don't get a perfect solution where you cannot divide it further, like 1 by 7. Let's try getting into decimal. What it become? 0.1, 7, 3, 7, 4, 8, 28, 3, 7, 4, 8, 28. 7, 3, 28, 2, 7, 2 is 14, 6, 7, 8 is 56, 4, 7, 5 is 35, 5, 7 is 49. And it goes on. It doesn't stop. If you, by dividing a fraction, if you convert that to decimal, it doesn't give you a perfect answer, perfect solution. These are called irrational numbers, or something like a square root of 2. Do you know what is the exact value of this? It will be a decimal that will not stop. It will keep going. Or square root of 3. Okay. If you try finding out the square root of 3, it doesn't stop. There is no perfect answer that you get. If at the same time if you divide 1 by 8, what you get? 0.125, and then it becomes 0. So it stops there. It doesn't go beyond this. But when you divide these kind of numbers, which doesn't give you a perfect solution, perfect answer, or doesn't stop, decimal keeps going, that is called irrational numbers. Meaning a decimal where you don't know how many decimal points it will go to. Okay, those are called irrational numbers. So when we look at the full numbers, we find whole natural numbers, all positives. Add 0 becomes whole number. Add negatives becomes integer. That's a group. That's a superset. Okay. When you look at fractions, all positive fractions are called simply fractions. If you look at positive and negative fractions also, that makes it rational numbers. When you look at fractions or a number which converts to decimal without having an end point to it, those are called irrational numbers. And when you put rational and irrational number together, that is what is called real number. See what's up?
Yeah.
Do you think I explain what is a real number
Yeah.
the way it was supposed to be learned?
Yeah, that's what my teacher told me.
Okay. So it's clear, right? If you are looking at whole numbers, full numbers without any fractions, there are three varieties. Smallest group is natural numbers where you have only positives. Add a zero to it, becomes whole number. Add negative, that becomes integers. That's a group. If you look at fractions, you're looking at all positive fraction, that is fraction. If you add negative fractions also, that group becomes a rational number. And when you're looking at this, fractions you can convert to decimals, right? 1 by 2 becomes 0.5. 1 by 4 becomes 0.25. Correct? 1 by 8 becomes 0.125. Yeah? When you are having fractions which you can convert to decimal or a decimal where you don't know the end point, those are called irrational numbers. And few of the examples for that would be things like a pi, things like a square root of 2, things like a square root of 3, things like square root of 5 and things like that. Okay? Where you don't get a perfect whole number or natural number. So those are called irrational numbers. So irrational numbers and rational numbers together, when you put them together, that's what becomes a real number. Okay? So real number is equivalent to an integer when you are comparing a decimal versus a full number. Okay? Srivastava, I hope I covered that concept.
Yeah, you did.
Okay. Alright, let's pick up the next topic. So Dikshita, were you able to follow what I said?
Yeah.
Okay. So, and kids, I call you guys kids, right? We're too old for being your friend. So in the class, if I'm teaching something and if I'm not explaining it well, don't hesitate. You have the rights to ask me as many times you want to ask till you are convinced about what you have learned. Okay? So don't hesitate. Just ask. Okay? Yeah?
Yeah.
Dikshita and see what's up. You guys are with me?
Yes.
Yeah.
Okay. Alright. So let's see what is the next topic that Srivastava has. And let's see if we know about it.
Yeah. Oh, I just looking up.
Equation, inequalities and relationships. That's what I remember.
Oh, yeah, I forgot.
Yeah. So, equation. When you look at equation, between the first one and second one, for you guys just to be able to read it, right? I have written 2x plus 7y equals to 5. And in the second one I have written as 3x plus 7. Just 3x plus 7. Here between this guy and this guy, the only difference is the first one has an equal to sign. That's why it's called equation. You have an equal to sign, that makes it called equation. If I have something where I don't have an equal to sign, that is called expression. Okay? So if I keep on smiling all the time, that is expression. There is no end result of it, okay? If I just smile, I don't say anything, right? You guys will say, oh, this guy is a good gentleman. He keeps on smiling all the time. But there is no outcome. I just smile. That is expression. There is no outcome. You're not saying something equal to something. There is no outcome. So likewise, smile is an expression. There is no outcome. If I just smile, if I don't say anything, you will not understand anything out of it. There is no action that you can derive from that. And that's why it is called expression. Okay, you are just expressing something, not doing anything. When you have an equal to sign, that's where it becomes equation. Now, that's the one difference. Now comes inequality. 2x plus 7 is less than 5. it behaves the same way as equation, but it is not equal to. That's why it's called inequality, right? Like you said, justice and injustice. Yeah. Same way, equality and inequality, meaning something which is not equal to. Yeah.
Mm-hmm.
Now let's go to the next level. That is, so equation expression we understood. What is inequality also we understood. Let's try doing a few sums, okay, on equation, and then we will be able to appreciate what it is for. Okay. So somebody says 2x plus 7 equals to 12. Okay, let me not make you guys deal with fraction. 2x plus 7 equal to 13. Solve it for x. Can you guys solve it?
Can you tell me the question again?
2x plus 7 equal to 13.
X equals
Find out the value of x or solve it for x.
X equals 3.
3.
Okay. X equals to 3. What did you do?
You subtract the 7
So-
from
Yeah. You are telling a story. Okay. Yes, okay. 2x plus 7 is 13. So if I move 7 to this side, plus becomes negative minus. So 2x equals 13 minus 7 equals 6. So x equals 6 by 2. And you got x equals to 3. So Sivatsav and Mithran both were right with the answer. I think Dikshita, you also got the same answer, correct?
Yeah.
Yeah. Okay. Now this is solving the equation. So tomorrow if somebody says, okay, find out 6x plus 7 equal to 14. Same way. Or let's say 6x minus 7 equals to 14. What will you do? Well, you will just do the basic operation, make.
Yeah.
When you have an equation, what you do? You put similar things together. Okay? Let's say you have a basket of fruit. Okay? Where you have apple, oranges, peach. Okay? And somebody says, okay, I'm giving more apples. And they dump more apples in the basket. What will you do? You will look at how many apples I had before, how many apples I got. You add the apples together. You have some bananas, you got some more bananas, you add the bananas together. So that becomes a new count for bananas or apple, whatever it is, right? So you add similar things together, right? You don't add apple to oranges, right? That's why people say you're comparing apples to oranges. We don't compare apples to oranges. We always compare or deal with similar things, okay? So same way, here what we do is, okay, this one has a variable, this is a constant value. So let me put all the constants together, okay? And I know how it works. If I have to move this guy to this side, I'll say, okay, 6x equals minus 7 becomes plus 7. So 14 plus 7. And then I can do the calculation, okay? So that's the basic thumb rule. Now, you mentioned a term called linear equation, right?
yeah.
Yeah.
What is a linear equation? Linear equation, let's look at something interesting about it. Linear equation, okay? If you break it into two parts, you see a line and then AR. So I'm not talking about AR as an augmented reality. I'm talking, let AR be separate, okay? What I'm trying to say here is, in linear, you see a line. What it means is, an equation is a linear equation if that helps you draw a line. So, if I have something like, let's say, 6x plus 2y equals to 7. What is the first thing that you noticed here? This is an equation with two variables. I have x as one variable and I have y as another variable. So this is an equation with two variables. Okay? And I will still call it a linear equation because the power to the variable is always 1. So here 6x plus 7y. Here the power to x is 1, power to y is 1. All the equation where you have power to the variable as 1, those are called linear equation because they help you draw a straight line. using this equation. Okay. I'm not sure if you have used linear equation to draw a line on the graph paper. Have you studied that already, or
We already did.
you already did?
Yeah, we did.
Okay, so now let's look at 6x plus 2y equals to 7 as a linear equation, and we will use that to draw a line. Okay, let's see if it works. How will you do it? Do you guys know how to do it?
Wait, I think I might remember.
Okay, I'll make it simple. Okay, if you have a linear equation with two variables x and y, okay, you will try finding out 2 points on the graph, and then you will join the two points to draw that line. Okay, here first point will be put value of x equals to 0. Let's put the value of x equals to 0 and see what is the corresponding value of y for this one using this equation. If I put x is 0, what happens? 6 into 0 plus 2y equals 7. 6 into 0 is 0. So that becomes 2y equals to 7. Y equals 7 by 2 or 3.5. So the first point I got was when x is 0, y is 3.5. So when x is 0, y is 3.5, somewhere here. I got first point. Okay. Now I will do the same trick by putting y as 0. So in the same equation I will say, okay, what happens, what is the value of x if the y is 0? So 6x plus 2y is 0 equal to 7. So 6x plus 2 into 0 is 0 equal to 7. So 6x equals to 7. So x equals 7 by 6. This will be a little more than 1. 1.1, 1.2 something. Yeah. So that means when y is 0, x is 1.1. So y will be 0 on this axis. X is 1.1. So I got second point. I will just join these 2 points. That becomes my line with the linear equation. Okay. And if you find some other value, okay, if you want to check that this equation forms a line, that means there will be another combination of x and y that will fall on this line. Let's say if you make x as 1, what happens? 6 into 1 plus 2y equals 7. So 2y plus 6 equals 7. So 2y equals 7 minus 6. So 2y equals 7 minus 6 is 1, y equals 1 by 2. Okay. So when x is 1, y is 1 by 2, meaning 0.5. Let's see. When x is 1, y is 0.5. See, it will be somewhere here. It will fall on the same line. Meaning you can extend this line also, and you will see that when the power of x and y, meaning both the variables in a equation is 1, it's called linear equation. The primary reason being, if you plot that on a graph, it makes a straight line. Okay. The time you make it like this, 6x square plus 2y, or any power which is more than 1, it becomes not any power. When you introduce something, a variable with power 2, that is called quadratic equation.
Okay, but I have a quick question. How can you turn the 6x plus 2y equals to 7 into y equals to mx plus b?
So that is called the slope intercept form.
Oh, okay.
So you can always convert this, right? So, but before I go there, whatever we have learned so far, are you guys clear with that?
Yeah.
Dikshita
Yeah.
and Srivatsa? Okay.
Yeah.
So when you look at a linear equation, essentially you talk about two forms of linear equation. One is called slope intercept form, one is called standard form. Okay. So slope intercept form is something like this: y equal to mx plus b. M is called the slope, this is called the intercept. Okay. Now, I am not sure if you guys have learned this before.
Yeah, I learned this.
You have learned this. How about you, Srivatsam, Dikshita? Have you guys learned about the slope-intercept form and the standard form of a linear equation?
Yeah.
Yeah. So basically, let's try relating that. Okay. So both are the same. Linear equation. Let's say the linear equation that we were dealing with, right? 2x plus 3y equals to 7. Let's say. I'm saying this as linear equation because both the variables have power as 1. That's why it is linear equation. Okay. The time there is a variable with power 2, this will not remain a linear equation because it will plot a graph. It will not plot a line. Okay. So we are dealing with a linear equation. Now, linear equation can be represented in two forms that we mostly use. One is called slope-intercept form. One is called standard form. Slope-intercept form is written like this: y equal to mx plus c or d, whatever. Okay. And standard form is written like ax plus by plus c equals 0. Okay. Now look at this equation, this one. 6x plus 3y equal to 7. If I bring everything one side, it becomes 6x plus 3y minus 7 equals 0. Now you can see this looks very much like a standard form, right? Here instead of a you have a 6, instead of b you have a 3, and instead of c you have a minus 7. This becomes the standard form. Okay. Now, if you map this with the intercept form, we'll talk about the intercept form also a little bit more. But let's first convert this. Okay. So 6x plus 3y equal to 7, and the intercept form says y equal to mx plus b. So let's keep y on one side and see what happens. So that means 3y equals 7 minus 6x. Yeah. Y equals 7 by 3 minus 6x by 3. Yeah.
Yeah, but can it also be 2?
It will be 7 by 3 minus 2x.
Uh,
So now this equation became y equal to minus 2x plus 7 by 3. Now you compare this with the slope intercept form. Instead of m you have a minus 2. Instead of b you have 7 by 3. So any linear equation with power 1 for the variables can be written in either slope-intercept form or standard form. Now let's look at slope-intercept form a little bit more. So far, Dikshita, Srivatsam, are you guys with me? Okay, because I can see Mitran right in front of me. I can see how confident he is when I am saying something, but I cannot see you guys. That's why I'm asking. Okay.
Yeah.
Okay. Dikshita, you are able to follow me?
Yeah.
Okay, good. Now, when you look at slope-intercept form, y equal to mx plus b or mx plus c. If you understand this against a graph, this m represents the slope of the graph. If the value of m is positive or negative, high or low, that tells you how steep, sorry, not the graph, sorry, how, for the line, sorry. That tells you how steep is the line, how is it standing straight, is it tilted, very shallow, it tells you that. So value of m, if it is positive, it is this way, if it is negative, it is in second quadrant. Okay, so basically m is the slope of the line. Is it steep or shallow? Is it vertical or pretty much horizontal? That's what the slope means, okay, in this one. And this intercept means where it touches the y-axis. So this is y-axis, this is x-axis, okay, meaning where the value of x is 0. When the value of x is 0, that means this part will be 0 and this will touch the y-axis. So in the slope intercept form, when you see an equation, the slope intercept form, whatever is the value of the constant, that tells you where that line touches the y-axis, and m tells you what is the slope, meaning what is the inclination of the line. Is it horizontal, vertical, tilted, very straight, likewise. Yeah.
Yeah.
So we will learn about that when we touch upon a little bit of trigonometry also, okay, because that is where you'll be able to relate that with the angle of the line, how that slope comes into picture, okay. So that's why I'm not touching that right now, but this is just a conceptual part, okay. If m is positive, that means it is in the first quadrant. If m is negative, that means it is in the second quadrant, okay. All right. Now let's look at one more concept. So this is on the equation and relationship and the linear equation, right? Now let's look at one more thing. What was the next topic, Sivatsav? You remember?
It is volume and surface area.
Volume and surface area. Very nice. Now, this is a square. Okay. A square is something. A square is a quadrilateral where all the sides are of same length and they are perpendicular to each other. You guys know about that, correct?
Yeah.
Dikshita, you are with me? Yeah? So when we look at the square, what are the things we end up deriving? Okay, I know that, okay, it has a side, it has 4 sides and all the sides are of same length and they are 90 degrees. So this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree, okay? And this is side. If this is length, this is also L, this is also L, okay? And from this we know, okay, we can find out the area and we can find out the perimeter. Yeah. Now let's bring a twist here. Meaning in this square, this is a 2-dimensional shape, right? Meaning I have length, width, that's it. Now let's bring the 3rd dimension to it. I made this square like a cube. Oh, Dikshita dropped off. Okay. See what's up, you are there?
Yeah, I'm still.
Yeah, okay. Dikshita dropped off. Okay, I think she will join back. So what I did was, yeah, welcome back Dikshita. Can you hear me okay? Can you hear me okay?
Yeah, I can hear you now. I just couldn't hear you before.
Ah, okay. Now, so what I was saying was that I started with a square. A square is a shape, is a quadrilateral which has all the 4 sides of same length and all the angles as 90 degree. Yeah. Now, and from that square, we know that we can find out the perimeter, we can find out the area, right? Perimeter is nothing but the length of the boundary. Area is nothing but the space that it takes. Yeah. Are you guys with me so far?
Yeah.
Okay. So when I say area of a square, I am talking about the space that it takes, right? For drawing the square. Now, so far things were looking okay. We were looking at 2-dimensional shapes, like a square, rectangle, triangle, polygon, pentagon, hexagon, whatnot. Now let's make life a little more interesting. what I did was, I extended that square to make it a cube. Okay? That means it is no more a thing which can be drawn on a piece of paper. It is something that you have to keep in a container. It will take space. Okay? Like me, like you guys, we cannot be drawn on a piece of paper. We take space depending on how big we are. If I put on more weight, I will need more space. I will need a bigger window, bigger door to cross. Yeah. I would need to eat a lot as well. Yeah. So that is nothing but the volume, the space that we take. Let's say if there are 50 fat people like me, okay? If I jump into a swimming pool, what happens?
You're gonna say
All the kids will have to leave that place because there are enough bulky people in the swimming pool, because we are taking volume. The swimming pool can contain certain number of people depending on how much the volume the swimming pool is. Okay? So volume is nothing but the space any three-dimensional thing takes. If you look at this guy, you are seeing the rectangle right now. If you look at like this is a dry eraser, right? It's a three-dimensional shape. It needs, you cannot put it on a piece of paper. It needs some space. Yeah? It needs volume. So there are two things here, volume and surface area. Volume is the total space it takes, meaning if you put this in a glass of water, water level rises. Whatever is the rise in the water level, that's the volume, the extra volume that it took. Okay? Yeah? And if you are looking at the surface area is nothing but the border, the size that you see. If I have to color it red, surface area tells me how much paint I would need. Okay, that is surface area. If you are looking at my water bottle, the volume is the amount of water it can contain. Surface area is the size of the sticker I would need to cover it completely or to paint it. Yeah? That's the basic difference. Now, the key objects or shapes for which you would need to find out the volume and surface area would be cube, cuboid, cylinder, pyramid, prism and sphere. Now tell me what all you guys know, what all you would need to know. Do you know how to find out the surface area of a cube and a cuboid?
no.
No. How about you guys? Srivatsav and Dikshita?
I forgot the formula.
Okay. I would not want you to remember the formula. I will make it easier for you guys. Okay. So let's look at cube and a cuboid. Okay. What is a cube? What is a cuboid? Let's try recalling that. We'll try closing there. Okay. We'll not go far. Otherwise, you guys will learn a lot of things and you'll get confused. So what is a cube? Cube is an object. Cube is something similar to an ice cube. Okay. Cube word was derived from the ice cubes basically. An ice cube which looks like a square from all sides, or a dice. If you guys have played Ludo or other stuff, right? Where you have a dice, a small object that you can roll, which has 6 numbers written on 6 sides. Yeah.
Yeah.
So that is a cube where every side is like a square, meaning length, width and height all are same. Okay. What is a cuboid? Cuboid is derived from a rectangle. If you look at a rectangle and stretch it like a brick, or even this eraser. See, this was a rectangle before. What I did a 3D painting, 3D drawing to add height to it. So it had length and width, now it has a height also. So volume of a cuboid is, this is length, this is width, and this is height. So volume of a cuboid, what is the area of a rectangle? Length into width, right? When you are adding height, that means you are expanding in the third direction. So length into width is the area, and you are extending or raising it upward. That's where the volume is length into width into height. I'm not trying to prove that right now, but I can prove it, okay? I can prove it in the subsequent classes, okay? How the volume is length into width into height, okay? So length into width into height. Now your cube is also similar to this, okay? So length into width into height is the volume for cuboid. Length into width into height. In case of cube, your length, width and height is all the same. So length into width into height becomes length into length into length. Okay? So the volume of a cube is length cube. Are you guys with me so far?
Yes.
Yeah.
So the volume of a cuboid is length into width into height. Primary reason being, a cuboid is derived from a rectangle. Rectangle's area is length into width. When I am expanding it, it's like if you look at your printer paper, right? The printing paper. If you look at the bundle that we get for putting in our printer, right? If you take sheets out one by one, you are actually looking at rectangles stacked on the top of each other. So many rectangles one after another, right? If you add more sheets, meaning more rectangles, it becomes taller. Yeah? So every sheet is length into width, and then how many sheets you are putting one after another as to the height. So it becomes length into width into height. Okay? So same thing is the formula for volume. So length into width into height is the formula for the volume of a cuboid. And cuboid and cube are similar in nature. It's like cuboid is made by rectangle, cube is made by square. So you can use the same formula. The volume of a cube will be length into width into height. Here in case of a cube, length, width and height are all the same. That's why it becomes length into length into length. That is length cube. And length cube. See, cube, volume of a cube is length cube. Yeah, easy to remember. Now, when you are looking at the surface area, if you look at the surface area of a, okay, let's look at the surface area of a cube. Cube first. Length, this is also length, this is also length, everything is same. If you look at a cube, or if you look at the dice that you would have played with, it has all the sides as square. So basically, it has 6 squares. If you see, 1 to 6, right? That is what is printed on the dice, right? It has 6 sides or 6 squares. Every side is a square, that is length square, that's the area. If you have 6 sides, so the surface area of a cube is 6 into length square. Because one area is length into length, all are same. And you have 6 sides similar to that. So that becomes 6 into length square. Are you guys with me?
Yes.
Yeah.
Dikshita, see what's up? No doubt, right? No, and feel free to ask me for doubt, okay? I don't think I teach the best possible way, okay? If you guys have doubt, feel free to ask me, okay? Now look at a cuboid. Cuboid is nothing but something like this, or even like my phone. Yeah, it doesn't have sharp edges though, but assume this is like a rectangle. Okay, what you are seeing is it also has 6 sides, and there are 3 pairs of similar sides. This side and this side are same. This side and this side are same. Yeah. So basically, you have 3 pairs of similar sides. Let me not try proving that formula now, because if I do that, you guys will get bored and you will forget it also. Okay? I will explain how the surface area of a cuboid is derived. Okay. Right now I'm just telling you it is 3 times length into width plus width into height plus height into length. Now how is what I will explain you in the next class. And you guys will think that I'm a super intelligent person that I remember the formula also. But actually I'm not. I remember this because I have learned it conceptually and I have just broken it down into simpler form to memorize this. Okay. When I explain this to you guys tomorrow, then you will also become as intelligent as I am sounding right now. Okay. Yeah. So I'm not very intelligent. I'm a hardworking guy. So whatever you see here, it is based on what concept I know, and I was just relating to that. Okay. Yeah.
Yes.
So that's what brings us to the end of the class. Now, before we disperse, our request to Dikshita and Mitran is you guys will note down all the topics. Like you mentioned, like Mitran gave me 3 topics, but I want the subtopics within that. Right? So that we can cover each and every topic, see what we know, what we don't, and how prepared are we for a STAAR test. Okay? I'm not worried about any of you struggling with STAAR test, but it is always a good checkpoint for us to make sure that we know everything that we are supposed to know. Okay? Yeah? So, before the class tomorrow, just please try spending 30 minutes sometime to at least list down the topics. Okay? That's what I want. So, like how we covered some of the topics, what Srivastava shared, I want to do the same thing for you guys so that for 7th and 8th grade, we start covering those topics one by one and we do some sums also so that we are more and more confident. I mean, you guys have to be confident, there is nothing to worry, but being a little more prepared, being more, structured with the approach makes you more confident. Yeah? Alright? That's what brings us to the end of the class.